We did yesterday, but it's a multiple, not a factor. Okay, a multiple is we take a number and we multiply it by 1, and we multiply it by 2, and we multiply it by 3. So look at this one here. Let's look at this one, number 9. Number 1 for the number 9. If I take the 9, 9, it's 9 times 1 is 9. 9 times 2 is 18. What's 9 times 3? 27. These are multiples of 9. In other words, I take the 9 and then multiply it times 1, then times 2, then times 3. Each of this is a multiple. Now when it comes to the number 18, what are some multiples of 18? Well, 18 times 1. What's 18 times 2? So 18 times 2, we get 16, 36, and so forth and so on. You keep multiplying by the different numbers. Now looking at these two numbers, number 9 and number 8, what is the smallest number they have in common? The 18. So the 18 is the least common multiple. So for 18 we have 18, 36. For now we have 9, 18, 27, 27. But the least common multiple is 18. Now these two are easy, because you just multiply by 1 and then 2 and then 3 and then 4. For that one, very straightforward. You don't really have to do much. But this one's different. Look at number 3. Oh, there is, but it's really way down there. Because if we do the multiples of 19, it's 19, and then 19 times 2 is 38. And then it keeps going. And somewhere in the future, there's going to be a number that 19 goes into and 3 goes into. It's going to be the smallest. Now we can do it by hand. This be 3, 6, 9, so forth and so on. And we do it until we get a number that matches up. Or in this case, this number's prime and that number's prime. So worst case, I take 19 times 3. If I take 19 times 3, that's 27.
Okay, I'm not playing this game with you. I make the other two walk around and not you. Yeah, right. Hello.
19 times 3. Shh. 57. Now if we kept doing that with a 3, we would eventually get 57, and multiply that by 3, you would get 57, and we go, okay, the least common multiple. Did I do it right? Yeah. So the least common multiple would be 57. But notice, if we did that multiplication, it'll take forever. So we can always, worst case, if it's a prime number, both multiply times each other. Number 5. The multiples of 6. Why are you guys late?
We got walk maybe you walk all the way around.
No, I was at my locker when I was kids at the locker.
Okay, give me some Nelson. Shh, Sean. What are some multiples of 6? 6 times 1 is what?
12.
What's 6 times 2?
12.
And Nelson.
Or 6 times 2, crap. 8.
It's 12. What's 6 times 3? So far, 6 does not go, 28 does not go into 20. 18 does not go, 28 does not go into 18. So you have to keep going. And eventually, now give me some multiples of 28. Well, there's 28. And what's 28 times 2? 56. And then times 3 is what? 28 times 3? 84? Okay. If we keep going, we'll eventually get to a number that they're both equal, that they can multiply into. But that's long. So this is what we're going to do instead. For almost every problem, we take each number and we break it into prime factors. So we take this is the step that always works for anyhow, small or big. Prime factors of 6, 2 and 3. Now we take 28. The prime factors of 28. 4 and 7. Do you have any primes so far? Well, we have this, this one, and that one. So those prime. Now this one, 2 and 2. These are prime. Now between the 6 and the 28, the 6 has 1, 2. The 28 has 1, 2. The 6 has a 3, but the 7 doesn't have a 3. 28 has a 7, but 6 doesn't have a 7. What numbers show up here? 2, 3. If we list them all, 2, 3, 2, 2, 7. Those are the numbers. 2, 3, 2, 2, 7. That's the prime factorization of both of them. Let's try. What's 6 times 2 times 3? 6. 12. 12 times 2? 24, that doesn't work. Oh, 7 times 7. It's 24 times 7. What's 24 times 7? 8, carry the 2. 14, 15, 16. 168. Give me 1 second.
They look brown. It look like they actually cooked it. I don't know if I understand. It ain't good. What are you doing? I mixed the cookie. I didn't mean it. That's what this called. This is called it.
Okay. You have to pay very close attention. Write this down on the sheet of paper. The first thing we did prime factorization for both. Shh. We wrote down the prime factorization for both. Then we look at the numbers. The number 6 has 2 once. The number 28 has 2 how many times? 2. So we take the biggest one, 2 times 2. Now what's some other primes? Well, 3. 3 only shows up once. And 7 only shows up once. The biggest. There is 2 7, it would be 7 times 7. But in each one, this one has the second one has the most, so we use these two. Then this one has the most, and that one has the most. So if you multiply that out, 4 times 3 is 12. 12 times 7, what's 12 times 7?
84.
84. Oh. So the smallest number that both of these go into is 84. And what we noticed what we did was, we could have just multiplied this by 2. Then for the next multiple would be 84. But using the prime factorization, we found it. Now let's see if we can do that for 30 and 13. 13 is a prime number. So 30, we break down 30 into what? You can do 3 and 10. Let's do 3 and 10 if you want. How do we break down 10? 25?
No, 2 and 5.
2 and 5. That's as far as we can go. Those are all primes. Now 13. Just 13, yeah, 1 and 3 are 13. So we have 2s, we have 3s, we have 5s, and we have 12s. What's the maximum amount of 2s that we have? We have 1, 2. What's the maximum amount of 3s we have?
2.
Oh, we just have 1. What's the maximum amount? There's only 1 3. Okay. How many, what's another prime that we have?
5.
What's the most times it shows up? Just once. What's another prime we have? 13. It only shows up once. So if we multiply that out, this is 6 times 5, which is 30. 13 times 13. Zero. 390. 390 is the smallest number that 30 goes into and 13 goes into if you multiply them out. That's the first thing you come to. There's probably more after that, but the least common is 390. We only have a few more. I think you guys are starting to get the hang of it.
If you say something like that.
3. The prime factorization for 3 is just 3. Because 1 times 3 is just 3. Now let's do 12. 3 and 4. Break down 2. Break down 4. 2 and 2. What's the most amount of times 2 shows up in one of the factors? No, it shows up twice here. Okay, so this is 2 times 2. The most amount of times it shows up in either one. 3. It only shows up once. Once in the first one, once in the second one. You choose which one has the primes. Let's say there was a 7, only in one. But here, 12 has 3, and 3 has 3. So the most that shows up in each one, once.
This is another way to do it, right?
You can multiply and not keep going, yeah. That's another way. So what's 2 times 2 times 3?
12.
12. That one you should be able to see. You know, they should be able to see. That one's not hard. This one you should also be able to see. What is the least common multiple of that one?
15.
Okay. If you do 15, let's do it the hard way. 3 and 5 and 5. The 3 shows up maximum once. The 5 shows up maximum once. So it's 3 times 5,
15.
which is 15. So like I mentioned before, no matter how you do it, the long way for the complicated ones or the easy way for the simple ones, it still works out. You should be able to see 13 off the top of your head. But maybe not. The smallest number that these two go into. That they go into both. 6 goes into something, 9 goes into something. The smallest amount. Well, let's say you don't see it. Yeah. But let's say you can't see it, so you get 6, you break it down, 2 and 3. You get 9, you break it down, 3 and 3. Okay, 2. What's the most times it shows up in either one? Once. 3s. How many times does it show up the most in either one? It shows up right here, twice. Yeah, it's a little confusing. See, because here it shows up once, but here it shows up twice. So you should use the bigger one. If it shows up twice, you put twice. So 2 times 3, 6. 6 times 3, 18. So the smallest number both those will go into is 18. That one you may or may not be able to see in your head. Martavius saw in his head. 15, last one. If you can't see it in the top of your head, okay, let's break it down then. 15, close. 3 and 5. Those are the prime factors of 15. Notice by now, this part, the prime factorization, boom, 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 boom. 8. 2, 4. 2, 2. So 2's, a 3, and a 5. What's the most amount of time that 2 shows up? 3 times. 1, 2, 3.
Oh, I see it.
How many? Most amount of times that 3 shows up? Once. The most amount of times that 5 shows up? Once. That's 4. That's 8. That's 24. 24 times 5. 120. This, if you do it by hand, you'll get 120. So the smallest number that 15 goes into and 8 goes into is 120. Go ahead and take out the paper I gave you yesterday, if you have it. Yes.
Either.
You were not here yesterday. showing. Right. Take one and then give this to Jamira.
Sean was here.
Thank you.
I was here.
Take that to Jamira. Let's go back to greatest common factor. On tomorrow's test, I'm going to ask for greatest common factor. And some of you are going to go, I know that. And you're going to give me the least common multiple. So we have to differentiate between the two. Let's do greatest common factor, the homework I assigned. So that you remember, okay, this is greatest common factor. What we just finished was least common multiple. Number 2 from your homework. It's just the prime factorization of 44 and then prime factorization of 22. That's how we start for both greatest common factor and least common multiple. If we break it down, this is 4, 11, 2 and 2. So it's 2, 2, 11. This is 2 and 11. That's as prime as we get. Now, because we're looking for not multiple but greatest common factor, what do we do with those numbers? All of them, or?
I'm asking you. Wait, so you look at the greatest common factor?
Greatest common factor, we did that yesterday. Notice the first is the same steps as least common multiple, which we did today, the first step. But now here it changes. For your homework, we did this. The biggest factor they have in common. Biggest factor they have in common. What's the biggest factor they have in common here? 11. So the greatest common factor is 11. That's the number that goes into 22 and 44. Now let's try number 4.
4.
This is 3, 4, 2, 2. This is 3, 9, 3 and 3. Here's the difference. This has 1, 3. This has 1, 3. This has 1, 2. This has no 2. This has another 2. No other 2. So what is the small, Jamira, please. What is the smallest number that goes into both these numbers? 3. Because the only factor they have in common is 3, and the least amount of times it shows up is once. So the greatest common factor is 3. These number 6, 7 and 35. You know 7. 5 times 7 is 35. We have a factor of 7. This one has a factor of 7. That's all they have in common. So what's the biggest number that goes into both of them? Smallest. 7. That one was easy. This one's a little more complicated. $38, 14. Let's do 14. Factors of 14. 27. Prime and prime. Factors of 38. 4 and 8 is 32. $38 is not prime because it's even. Probably worst case we divide it by 2. 3. 19. 2 times 19 gives you 38. 19 is prime. So let's see what numbers they have in common. We have a 2. And that's it. Nothing bigger. Because this one has 19, the other one doesn't have 19. The other one has 7, this one doesn't have 7. So this biggest number they have in common is 2. Just a couple more. 48. And 32. 48. Break it down for me. Any factors? Very good. 6 and 8. 6 breaks down to 2 and 3. 8 breaks down into 2 and 4. 2, 2. The factors of 48, I'm going to write them out because I got confused with these numbers down here. It's 2 times 3 times 2 times 2 times 2. All those numbers multiplied out give you 48 in the prime factorization. Now 32, what are 2 factors of 32? 4 and 8. This breaks down to 2 and 2. 8 breaks down into 2 and 4. This is 2 and 2. So the prime factorization, is 2, 2 times 2 times 2 times 2. So they have 1 in common. They have another in common. They have another in common. Another in common. They have 4 2's in common. Because they have 4 2's in common, it's just 2 times 2 times 2 times 2. 16. Now looking at our options, 48, 16, yeah, it looks about right. 16. Hi, you went yesterday. Yeah. Okay. Hey, you went the day before. You did. That's it. You went. Jason. Number 12. Come hither. Okay, he's going to do number 12. Please pay attention to what he's going to do. First, break down the 28.
How do I erase?
How your finger?
Move your finger.
4 times 7. Marquise. Marquise. 2 times 2 times 7. That's the prime factorization for 28. Ladies. 14 is 2 and 7. Now circle what they have in common. They have 1, 2, and they have 1, 7. So the greatest common factor is 2 times 7, which is what? 14. The biggest number that goes into both of them, 14. Two more. 14. Actually, one more. 40. Prime factorization for 40. 10 and 4. 16. 10 and 4. We could also use 5 and what? 5 and 8. Let's do 10 and 4. That's fine. This is 2 and 2. This is 2 and 5. So if we had to do it again, and this is 2 times 2 times 2 times 5. That's the prime factorization for 40. For 18, 2 times 9. 9, break, shh. 3 times 3. So it's 2 times 3 times 3. What factors do they have in common? Well, they have a 2. And that's it. They have nothing else. The other one has a 2, but the bottom doesn't. 5, bottom doesn't. So the greatest common factor of these two is 2. Which one? Oh, we just did it. Oh, we didn't? Oh, okay. 7. That's 2 times 7. 7. 7. Fourteen is 7. 7 goes into 7 once. 7 goes into 14. 16 is 2, yes. Tomorrow when you turn it in, you're going to turn in everything, including the sheet I gave you today.